Hey guys, so I'm Sam. So let's continue making our minesweeper bot in Python. So if you remember last time we had written enough code so that we could read this board accurately. So I think if you've still not yet reached this stage or you want to figure out how to reach this stage, watch the previous videos. But from this lesson on, we will, I mean not this lesson, this video on, we will go ahead and try to figure out how to make this all a little bit more appealing. This code is a bit of a mess and it's not very extensible. So the first thing that we'll do is we will create some items, some objects. So which would be essentially, I use objects as data structure. So I'll create a new classes.py. So let's just classes.py contains all data structures for loopstick. Yeah, so I like to do it this way because it creating these in a separate file would be helpful. So we'll have two classes, one will be minefield and one will be tile, right? So this will allow us to very easily kind of work with all of these. So as you see here, we are kind of using position 0, not position 0, where was that click? Oh, that click is not even in this. So we were clicking tiles based on on indexes, whereas that's not the best way to do it, and that's definitely not the most readable way to do it. So having these classes would be very helpful. So let's just def init self. So we need a width and a height and tiles. So I think that's mostly all that we need. Self dot width self dot height is equal to height, and self dot tiles to tiles. Perfect. And for the tiles, so what I am thinking of is tiles will just be a list of object tile, and then we will use the index in that list to refer to tiles, and then you can basically build a graph out of that, but we won't be really doing any graph based operations. So self, it'll have a position, it'll have index first, of course, it'll have a position and it'll have a value. I think that's good. Self dot index equal to index, self dot position is equal to position, and self dot value is equal to value. So I think that's good. So let's come back here and figure out, let's import that first. So from classes import minefield and tile, right? So let's then put all of this into, I think this can be outside. Let's put this into a function, read minefield. Yeah, perfect. Let's indent this. So all tiles, then for each tile, I think even this has to be inside. This is going to be a separate, the display will be a separate function. So for perfect width, so I think we can even get a height out of this, cw height, and so now we have the height. And then let's also create the tiles. So tiles, I don't think we've used this anyway. Perfect. So tiles is type index, I think it was index position and value. Perfect. So so here there's just position and value, position and value stored. So we'll also want to create the index. So for tile I comma x position, and let's call it t. That's a little bit better. We're using x everywhere. It's not very clear. t value. Perfect. T value, but close this. So that looks right. So for t in all tiles. Then we can generate the mine field. So we'll say mine field is equal to mine field. I think it was height width. No, it was width height and tiles. Perfect. And then we'll return that. So this just clears up the main function a bit, rather than just doing everything procedurally. We can now have at least easier flow. So yeah, width height tiles, that's correct. So having these functions is going to make it much easier to read the main control loop. So this can actually go, because it's no longer all tiles. So let's create a def display minefield. Yep. So how would this work? We're not going to go in all tiles. We're instead going to go, let's indent this again. For I comma tile in enumerate all tiles. So I don't think we need I because we have index. So we can remove this. And it's not all tiles, it's going to be minefield dot tiles. Okay, so then print tile dot value and if tile dot index +1 width is equal to 0. Perfect. And then let's create a main minefield is equal to read minefield and display minefield. So then let's run this. If name equal to main. Alright, so this is restructured a lot and I think it looks considerably better now. So let's just make sure this runs again, because we've actually not added any functionality. We're just hoping that the current functionality works. So let's see. So this is, okay. Oh, here I will have to enumerate I comma t enumerate. So this enumerate can bite me a lot. At least I keep forgetting it because I is so clear in the code that I forget to actually define what I is because I is just the general counting variable. So let's see how that refactoring works. Width is not defined because I have to say minefield dot width. That makes sense. Minefield dot width. Alright. Let's put some spaces here, make that a little bit more readable, and let's see if that works. So I actually enjoy this process of refactoring. It generally so that looks right. So okay, awesome. So now we're back to feature parity, as it's sometimes called. So now basically all of these functions can now exist on their own, and I can make whatever changes here, and I won't have to make any changes here. So minefield, read minefield, and display minefield. So that's good. So I think now we're in a good position for this video. I think we'll end this here. This was just quick refactorings to make it a little bit more readable. So let's get status this modified add. Alright, so git add both git commit am refactor functionality has changed. So even in last video I hadn't shown the git comments, but I did end up making them once the video was over. So yeah, I've pushed that as well, and I think now we're in a good position to end this video. I hope you guys enjoyed. If you want to, I think next time we will actually go and start the interesting part, which would be the basic algorithm. Alright, thanks guys.